The universe is thought to have begun as a singularity, an infinitely dense and hot point in spacetime. This singularity expanded and cooled, giving rise to subatomic particles and eventually atoms. These atoms eventually came together to form stars and galaxies. As the universe expanded and cooled, matter began to clump together under the influence of gravity, forming the first galaxies and stars. These early galaxies were composed mainly of hydrogen and helium, with trace amounts of lithium. As the universe continued to expand, gravity pulled more and more matter together, forming larger structures such as galaxy clusters and superclusters. As stars formed and evolved, they also seeded the universe with heavier elements, through the process of stellar nucleosynthesis. These heavier elements allowed for the formation of planets around stars, and eventually lead to the emergence of life on Earth. The history of the universe can be divided into several key eras. The Planck era, from the singularity until 10⁻⁴3 seconds after the beginning, in which the four fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, are thought to have separated from a single unified force. The Grand Unification era, from 10⁻⁴3 seconds to 10⁻36 seconds after the beginning, in which the strong nuclear force and electroweak force separated from each other. The electroweak era, from 10⁻36 seconds to 10⁻12 seconds after the beginning, in which the weak nuclear force and electromagnetism separated from each other. The hadron era, from 10⁻12 seconds to 10⁻6 seconds after the beginning, in which protons and neutrons formed from quarks and antiquarks. The lepton era, from 10⁻6 seconds to 1 second after the beginning, in which electrons and other leptons formed. The photon era, from 1 second to 380,000 years after the beginning, in which the universe was filled with a hot, dense plasma of protons, neutrons, electrons, and photons. The Dark Ages, from 380,000 years to around 100 million years after the beginning, during which the universe was dark and mostly composed of neutral atoms, with no significant sources of light. The Stelliferous era, from around 100 million years after the beginning to the present, during which stars formed and have been continuously forming. The Degenerate era, which would be in the distant future, where stars would have exhausted all thermonuclear fuel and the universe would be composed of white dwarfs, neutron stars, and black holes. The Black Hole era, which would also be in the far future, where the majority of matter will have ended up in black holes, and the energy output from stars would be negligible. Heat death, which would be the end state of the universe as we know, where no energy is available for work and the universe reaches a state of maximum entropy.